Hello friends, so welcome back to my channel. Today we are going to see what are index in SQL Server. So as usual, the agenda would be understanding index in SQL Server. Typically we would be looking at three type of indexes: clustered, non-clustered, and covering index. We would also talk about what are heaps in SQL Server. I would show you some practical demo as well. So let us understand first what are indexes. SQL indexes are used in relational database to quickly retrieve data. They are similar to indexes at the end of the book whose purpose is to find a topic quickly, right? So in very, in a simple terms, indexes basically helps us in retrieving the data in quickest manner, right? In a faster manner. So whenever you have a indexes on a table, right, data retrieval becomes much faster. And it is said that it is similar to the book indexes, right? So let me give an example. Suppose you have 1,000 pages of books, right? And everybody knows either on the first or the last part of the book there is an index where initially there are chapters, against each chapter, and then under chapter there are topics, and against each topic the page numbers are written. So this is where this page number is basically is to find quickly the topic. Okay. So for example, if you want to find some topic, then you simply go to that chapter, or you had to browse only a single page. You need to find that topic under the chapter, and then just go to that page, and that's it. You got your topic and you can start reading it. Similarly, index works in the similar fashion in SQL Server, or for that matter on any databases. Okay. An index contains keys built from one or more columns in the table or view. These keys are stored in structure B tree that enables SQL Server to find the row or rows associated with that key values quickly and efficiently. Right? So it's not necessary that only one key column can be associated with the index. You can have multiple columns, key columns associated with an index. And generally, it is said that clustered index should have only one column as a key into the clustered index, but it's not mandatory, right? Now, when we talk about B-tree structure, so this is a basically B-tree structure. We got this picture from sqlshack.com, right? Uh, this is B-tree structure. So first is the root node, then a intermediate level and leaf node. So basically there are three parts of an index. In an index in B-tree structure, there are three parts. The first is the root node, where actually the index, actual index starts, intermediate level, and the leaf node data pages. This leaf node data pages basically contains the final data which is retrieved by the index. So this is a B-tree structure. Okay. How many types of indexes are there in are possible in SQL Server? So you can see the list: clustered, non-clustered, index with included columns. Sometimes they are also called as a covering index, filtered index, special index, XML index, full text index, and column store index. Okay. In this session, we are going to see what are clustered, non-clustered, and index with included columns. Along with that, the heap. Okay. So let me talk about the heap first, right? So what is a heap? See, when table does not contain any of the indexes, then it is called as a heap. Okay, when there is no index present, it is called as an heap. Sometimes heaps are very advantageous. So, for example, if you have a very small amount of data into the table, for example, master tables like status records or something like that, then it is always good that heap, because anyway, and SQL engine might not use the index present on that table, and then unnecessary, you will have to maintain that index. Okay. So basically, heaps are what? Uh, they are the simple table where no any type of index is present. Okay. So as usual, let us see something in action. Okay. So first of all, let me create one table here, parts table. Okay, and I am creating one clustered index CL parts. My cluster index name is CL parts part ID on parts table, and the key column which I have used is part ID. Okay, so let me create this clustered index. Okay, it has been created. Let me show you where this index, sorry guys, let me show you where this index lies. Okay, when you expand the table, expand the parts table, and there it is index 6. And you can see here CL parts, part ID, clustered index has been created. Okay. Now, let us talk about the clustered index first, and then I will show you how it is being used, and what is an index scan and what is a index seek. Okay, there can be only one clustered index on a table. Why? Because whenever you create a clustered index, the records, the data into the table is physically arranged by the key columns actually present into the your clustered index. So here, part ID is our key column, right? So all the data into this table, whatever we are going to add, all the data would actually get physically arranged. The B tree structure which we saw, so it will get physically arranged into this index and in the table, right? And that's why there can be only one clustered index and not more than one, because you cannot arrange your data physically in two ways. It can be arranged in one way only. Yeah, but one thing is sure that it's not necessary that you can have only part ID. You can surely have a part name also as a part of an index. In this case, uh, the index would be created on part ID and part name both. Okay, so let us move ahead now. So we have already index in place. Let me insert some values into this. I have inserted a value, and now let us start, uh, querying this parts table. Before that, let me get an execution plan for you guys so that I can show you how indexes are being used. So initially, I am saying select star from parts. Okay, and let us see on execution plan. So you can see here clustered index scan is being used, right? It is not using seek. Why? Because we didn't had any where predicate first of all, so it didn't, SQL engine doesn't know that what to seek, what exact value need to be actually fetch. It has to fetch, as we have said, as we have queried select star from parts, it has to actually query whole table, and that's where this clustered index scan is happening. Okay, we already have a clustered index, so it is actually scanning the clustered index and getting results for us. Okay, now let us see what happens in next statement. So select star from parts where part ID is equal to 1. Now here you can see here clustered index seek is used, right? Why? Because we have the clustered index present, okay, and our key column is part ID, and that's where this index seek is happening, because we are saying where part ID is equal to 1. Okay, so this is what a difference between cluster index scan and the cluster index seek, because we are actually filtering the data by the key column of the clustered index. Okay, now let us say we have a part name also. So now let us query the parts table with the help of part name. Okay. So when I execute this, and now if we see again, it has gone back to cluster index scan. Why? Because the cluster index doesn't have any information on the part name. So to find a part name is equal to 4, it has to scan the whole index or the whole table. See here why cluster index scan is being shown, because we have a clustered index which is arranged physically. Data in the table is arranged physically as per the clustered index, and hence we have, we are seeing this clustered index scan. Right. Now, cluster index doesn't have the information on part name is equal to 4, and that's why it has gone into the scan. Okay. Now, let me create one non-clustered index. Okay, so you understood what is clustered index, right? Now, non-clustered index. Non-clustered index is also a type of clustered index only, but the data is logically arranged. So you can have, and that's why you can have multiple non-clustered index on a table. Okay, because physically data is not arranged as per the key column, but logically it is being arranged, and there is always a pointer to the cluster index. So the cluster index key is always maintained with each record. So whenever even non-clustered index does not fulfill basically what basically the all the data, right, does not fulfill the key column, does not fulfill whatever we are finding, right, the filter predicate, then it has to go back to the clustered index. Okay, so let me create a non-clustered index here, and let me show you. So you can see now there is one clustered index and one is non-clustered index, and now I am executing the same select statement. And let us see execution plan. Index seek, see, the index seek has happened, but this time it is not a clustered index but a non-clustered index, right? Now, as I told you that non-clustered index always maintain the cluster, always have the clustered index key information also. And here we are actually fetching only two columns. That is, you can see here part ID and part name. So part name is already present into this non-clustered index, and part ID is also there because it's a cluster key. Okay, and that's why when we see here in execution class, it is happening an index seek. Okay, now what I am doing, I am actually using, so this is a non-clustered index. Now let us see what is an included index or a covering index. Okay, now I am actually altering this table and I'm adding one more column called as a part type. Okay, let me add this. Part type has been added. You can see here. And now, I am actually giving the hint to use the original non-clustered index because see, the table is so small that SQL engine may not use this index itself. Okay, and hence I'm giving this hint here. But otherwise, this query remains the same. The only thing is I have included the part type also in my final output. So when I execute this, you can see part ID and part type are fetched, right? But for what part name? For a fork. And now here, if you can see execution plan, this is where, the use of clustered index is being done. So basically index seek is happening. Why? Because with this index, we have the information on the part name and we are filtering the record with the part name. But this index doesn't have any information on a part type. Okay, because that column is not present into our index. Okay, and that's where what happens that though index seek is happening, but this index has to refer back to this clustered index, right, to get the information on a part type, and that is happening through the cluster key, that is part ID. Okay, and that's where this key lookup has been generated. Okay, so now let us create a non-clustered index, one more non-clustered index, and see part name included column. This is the name of an index. Again, my key column remains the same, but here I am using the include clause and I'm using the part type. So what is happening? I'm creating one more non-clustered index, and this time with the part name, I'm also storing the information of a part type as well, right? So let me create this index and let me refresh this for you. And you can see here our index is there. Now, instead of using this index, I'm using this newly created index. And let us see what happens. Oops, sorry. So what is happening that you can see here in execution plan index seek is happening now. Which indexes it is using? You can see here NC parts part name included column. Why? It has not gone through to the clustered index because now this index contains all the information we required. That is part name happening on the filtering, the part type, also we were using one column, and part ID, you always know that whenever clustered index non-clustered index is created, clustered index key is always there as a pointer, right, to be used for seeking some other column information from clustered index. Okay, and that's where now this is happening in index 6. So this is sometime called as an included index, or sometime it is some people call them as a covering index. Why covering? Because we have covered all the requirements of a query into an index, and that's where this is called as a covering index. Okay, so this was related to heap, clustered index, non-clustered index, and basically uh, covering index. Now let us do look some administrative part. So if you want to see, basically whenever you create an index, right, they need to be maintained. They need to be rebuilt and reorganized from time to time. Otherwise, if a lot of fragmentation happens, right, then again, though index is present, your query would start degrading. Okay, so there are two ways from UI. You can right click and you can say rebuild or reorganize. Okay, or within TSQL statement, you can say alter index, the index name, right? On clause, and this is the table name, and you can specify either rebuild or reorganize. And when you execute this statement, this index would get rebuilt, right? But what if you have, more than 10 index on a table? right? Then you will have to write this statement for each and every index. So there is an alternative called as an all clause. So you can say alter index all on table name and then rebuild. In this case, all the indexes on a table would get rebuild. Simple, right? Similarly, if you want to drop the index, right click on the index and just press a delete, or you can say with the help of for a TSQL statement, you can say drop index again index name on the table name. So whenever I execute this statement, and now if you refresh this, you can see this index is gone. Okay. So this was related to indexes on SQL Server. You know, we have covered clustered, non-clustered, and covering index and heap also. I hope you have understood this and you have enjoyed this video. For getting more insight or getting more knowledge on this, please research more on this. You know, try out some examples on your own so that you will get more knowledge. Okay. So, thanks guys for watching these videos. Hope you have enjoyed it. Uh, as usual, please don't, forget to subscribe my channel so that whenever I come up with new videos, right, you would actually get notification. I'm also going to start a video series on Postgres SQL as well in a future in couple of weeks. Okay, so please subscribe to the channel and yeah, that's it for today. Meet you next time with next good topic. Till then, bye. Take care.